This is the second video for January 3rd, January 4th. We're looking at factoring, different types of factoring. I left you and said try these next three. So you want to pause, check your work, see if you got these right. If not, come and ask me. I can answer this question, see what you got wrong, talk about that. Or if you want to try to figure it out on your own, that's probably the better way to go about that. But those would be those three, and then this would be the factoring for the quadratics. So if you want to pause, make sure you got those right, check your work, see if you made a mistake, learn from your mistake. Highly recommend doing that. All right, I'm going to go ahead and flip to the back side. Let's go and talk about these other two types of factoring. Here we have what we call difference of two squares. The reason it's a difference of two squares is because here it's something squared minus 25. Well, we can rewrite 25 as a quantity squared. And that quantity being, I'm going to put in parentheses, 5 squared. So here we have something squared minus another thing squared. Anytime that we have that situation, it only works if it's subtraction, not addition. Then we can factor this as x, like almost ignore the squares. X and 5, x and 5. So almost basically ignore the squares here. I put the x and the 5, and then one's positive and one's negative. And there's your factorization. So if we can rewrite quantities as squares and we're subtracting the two, then it does factor in this way. If I were to FOIL this, just so that we can see why this is true, x times x would give us, I'm going to do it up here, x squared. X times negative 5 gives us negative 5x. Positive 5 times x is positive 5x. And then 5 times negative 5 is negative 25. These two quantities are like terms. We have a negative 5 and a positive 5, though. So those would go away and we're left with negative x squared minus 25, which is back to our original. So that's why this factorization works, and this is our factored form. All right, so let's take a look here. Here we have 9x squared minus y squared. We already have this entire quantity written as a square. But now we want to figure out, can we write this quantity as something squared? Or in other words, what would have to go in the parentheses here to get 9x squared? Well, we already know that if it's x squared, then we need an x in there because x squared is x squared. And then 3, since 3 squared is 9. And now that you have a quantity squared minus another quantity squared, this would factor as 3x plus y, because 3x is the quantity that's being squared, y is the quantity that is being squared, and 3x minus y. Talk you through this one a little bit and then let you try these two on your own. Similar thing. Think about trying to rewrite this as something squared minus something squared. Well, if we remember properties of exponents, if it's a power like this, a power raised to a power, then what you do with the exponents is you multiply the exponents. So here, if I have x to the 6th, I need x raised to another power that when multiplied by 2 gives me 6, so that would be x cubed. Similarly, this would be y to the 4th, since 4 times 2 gets us 8. Now it's a very similar thing. I have a quantity squared, the quantity here is x cubed. Another quantity squared, the quantity here is y to the 4th. So we can rewrite this as x cubed plus y to the 4th times x cubed minus y to the 4th. Again, it's a difference of two squares. We look at the quantities that are being squared. This case, a little different, but the quantities, it's similar concepts. The quantity being squared is x cubed here, so that would go here and there. The quantity being squared here is y to the 4th, and so that's how that would factor. Highly recommend you pause, see if you can factor these. I will write the factorization for those two at the end of this video to see if you're right, but I would recommend pausing it now and seeing if you can do that on your own if you haven't already. Now let's go here. Okay, so these guys, similar thing to what was on the front side. You have a quadratic. You have a square term. You have the quantity with possibly a number in front of it here, like x squared, x, and then a constant. X squared, x, and a constant. X squared, x, and a constant. Anytime we have that quantity squared, the quantity, and a constant, that's going to take what we call a quadratic form. The big difference here, though, is the leading coefficient is no longer 1. We actually have a number in front of x squared. Two ways that I'm going to show to do this. Pick whichever one is you are more comfortable with. The first one is probably the quickest way, but it takes a little more number sense and thinking than the second one. And what's happening here is I'm going to open up two parentheses because I am factoring a quadratic. What needs to happen is I know that this number here, when I FOIL multiplied by that quantity there, this times this should give us 3x squared. So I need to split up 3x squared so I get one here, like whenever I multiply these two things, I get 3x squared. Well, the numbers that multiply to give us 3 are 3 and 1. So let's call this 3x and this 1x, or just x. So then if I multiply 3x times x, I get 3x squared. All right, so that works. Now, though, I need to figure out these two numbers. If I multiply these two numbers, then I should get -5. So now I'm playing around. It's like a numbers game. What two numbers multiply to give us -5? Well, let's say -5 and 1. Well, if I give this +1 and -5, and FOIL, 3x times x is 3x squared. 3x times -5 is -15x. 1 times x is x. And 1 times -5 is -5. If I look back to my original, 3x squared, good. The -5, good. But I need these two to combine to -2. That doesn't happen. So this is not the correct factorization. Those first two, all good. These last two, not so much. So now I need to play around with it again. Let's say -5 and +1. So this one didn't work. 3x times x is 3x squared. 3x times 1 is +3x. -5 times x is -5x. And -5 times 1 is -5. Again, we're good here, we're good here. Now let's check the middle. +3 minus 5, -2, which is what we wanted, boom. So this, after doing some trial and error, provides us the correct factorization. And now there is another method. So if you are like, hey, that made sense, I think I can get that with more practice, some more number sense, please, I recommend that. It can be quicker. This way is a trick and it's a process and you have to remember steps. It's called the AC method. Now this will work, but you have to remember steps, and there's some tricks in here that don't necessarily make logical sense. So I don't know, up to you. What the AC method says is I take the A value, which in this case would be 3, and I multiply it by the C value, which in this case would be -5. When I do that, this would become -15. Everything stays the same, but this 3 disappears. Now I have a quadratic that we can factor like on the front page. Find two numbers that multiply to give us -15. Those same two numbers multiply to give us -2. That would be -5 and +3. -5 times 3 gives you -15. -5 plus 3 gives you -2. But since you multiply by 3 here, we're not done yet. We got to put that back into like this here. That 3 doesn't just disappear. So because we multiply by 3 here, that 3 comes into play down here by dividing each number by 3. And this does not simplify. So this becomes 3x minus 5. The 3 goes in front of the x. This does simplify. 3 divided by 3 is 1. And so there is your factorization. Those are the same. Okay, so that one does take a little memorization of steps and processes, but it does work. I would recommend trying the next 3. I'm going to give you the next 2 solutions for these and go back and give you the, excuse me, factorizations for the ones up here. So those are the factorizations for those 2. I would recommend trying that on your own. Pausing, make sure you get that. And then if you tried these, this is what those factorizations would be here. Again, if you have questions, please pause, rewind. You can always ask me questions through the Remind app, email, website, however best works for you. We'll continue working with these over the next 2 classes and then transition to factoring with trig later next week.